question I have from a customer is, when would you use an Adams Rite 8099M2? And an 8099 is a touch bar. So all it is a touch bar. It's a dummy bar, or it's not a dummy bar in the sense that it's just there to look good, to match the other bar. It actually has, this 8099 has functionality. It's an M2, and what that means is there are two monitoring switches in it. And really all that means is inside of the device there are two single pole double throw micro switches in it. And to boil that down even further, basically when you hit the touchpad, you're going to change the state of those two micro switches from either wired normally open to normally closed, or normally closed to normally open, or one is normally open to closed and the other is normally closed to open. And I'm going to show you what that bar looks like right now. I have the touch pad removed from it. This is just a piece of extruded aluminum. And there's really not a lot to this device. Here it is. Okay, so when you hit that touchpad, that's all that's happening. The touchpad is just being pushed back out. There's nothing mechanically being engaged at all. There's no latch. This is not a rim device, a vertical rod device. This is just a touch bar. Well, this is the M2 part. So there should be 6 wires coming off of this. Yeah, there are. 2 reds, 2 whites, 2 blacks. Okay, let's not get ahead of ourselves on that. That's easy stuff. When the touch pad is pushed, it throws down this lever. That action is what changes the state of these micro switches. To get even closer in there, you'll see right at the tip of my finger, albeit a little bit blurry, you've got a black wire, I think on top of a white wire. Yeah, a black wire on top of a white wire on top of a red wire. Okay, there's one on this side, and then there's one here, and then there's one here. So there's just literally 2 of them. So the question from the client is, what would you use that for? Well, quite frankly, you could use it for a lot of things. And because it has 2 switches in it, you don't have to use both switches. You can use one. There'd be really no reason to not use either of them. Otherwise, it's just a dummy bar. But a common application would certainly be an application where I see it all the time, is you would be able to hit that touchpad and you would be able to open a circuit to something or close a circuit to something. So a typical application could be touchpad to a magnetic lock. You hit the touchpad, that single pole double throw switch is going to open the circuit. That mag lock is going to unlock, allowing you to exit. So that would handle one of those switches. You know, the other thing that you could use the other switch would be for is to turn on an air curtain. So let's say you've got a mag lock and you hit it and you exit, and immediately the air curtain comes on. And an air curtain kind of looks like an overhead door operator, except that it's bigger, and it forces air straight down across the plane of the elevation of the doorway. And those are used really common just to keep insects out. So that would come to mind. Obviously, more basic situations could be just talking to access control. Okay, so one of the 2 micro switches can basically tell you the touchpad is pushed out. When you push it in, it'll change the state of the micro switch. That could write to access control. An audit trail, basically. When was that touchpad pushed? The other touchpad could be to a siren. So let's say that you have, you've got audit trail, you've got a siren. Maybe not a siren, because there's no locking on this device. But it could be an indicator that the doors, some sort of indicator that the door has been pushed, a visual or audible indicator. But generally you'll have some locking hardware that's going to be released, and then some other action. So probably writing back to access control for an audit trail and unlocking some sort of a fail-safe device is probably what this would handle. So I think what we'll do is let's dive. If that's all you needed, great. Whatever you can control, two micro switches with, two single pole double throw, is what this would be used for. So all these wires will do is either turn it on or turn it off, depending, or turn it off or turn it on, or one of each when you push the touchpad. Whatever you want to open or close a circuit to, you got two times what I just said is what this does. So it's controlling other pieces of electrified hardware by pushing the whatchamacallit, the touchpad. I think so. There's two blacks, two reds, two whites. On each switch, there's a black, red, and white. Let's switch to a different camera view and let's discover what those wires are. I can tell you what they're called. One's normally, one's common, one's normally closed, and one is normally open. So we'll get our multimeter and we'll check when we have continuity on those switches just to understand a little bit better what they're used for, and maybe we'll go so far as to actually power it. So let's put it into a electrified circuit and see what happens. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, let's take a closer look at what the deal is with this. This does include some installation instructions, and it would elevating our discussion a little bit further. They're showing one of the micro switches here, basically, where there's a lamp remote that's on when you have it wired in this configuration. When you touch the pad, the swinger is going to go to normally closed, and it'll turn that light off. So you could do this scenario with one of the two micro switches. Over here is the same scenario, except that when you hit the touchpad, it will illuminate. This scenario will turn the light off when you hit the touchpad. This will illuminate when you hit the touchpad. The issue with that is it's only going to be illuminated for as long as you've hit the touchpad. When you let the touchpad go, that light's going to turn back out again. Well, down here, using one micro switch, is they show how you can wire it where you can have one light on and the other light off until you hit the touchpad. Then that light's off and this light is on. Now, they don't have to be lights. They can be horns. They can be cell phone auto dialers. They can be locks. They can be whatever the imagination leads you to. So this is what comes with it. So the question really becomes is translating this into what these wires are. We've got 6. Let's not think of 6. Let's just think of 3, because there's 2 sets of 3. The common is one of those 3 wires. There's a wire coming off of normally open. Just think of this being a wire, and think of normally closed being a wire. So there are 3 wires. The common, normally closed, normally open. So we know that the position of the switch is like this. So using our multimeter and checking for continuity, continuity is one of the settings on a typical multimeter. It's got a little horn on it. So the basic functions I use a multimeter for is checking continuity, measuring ohms, which I don't do often, but if you want to know if a motor is good or not, that's what you'll do. Measuring DC voltage, measuring AC voltage, and then I have in the past measured temperature. It's nice to know how hot something is when someone says, wow, that's really hot. Okay, well, how hot is, wow, that's really hot. You can measure that with this. I've done that in the past. I don't do it often. So if I'm using this, I'm checking for the presence of voltage, and I'm checking continuity. When you check for, when you're identifying what the wires are in a micro switch, you're checking for continuity. So I've got this set to continuity. Now what you're going to hear is a buzzing sound. So when you have continuity, so I don't know what wires are what. The only thing I've got to make sure is that I've got them all on one leg, meaning one of the micro switches. Otherwise, I'll never get it sorted out. Yeah, this is on the left-hand one. This black wire is on the left-hand one, or the switch closest to me. It appears as if this white wire. So these 3 go together. One of these is common, one of these is normally open, and one of those are normally closed. So And I'm going to grab one of these wires. I don't know what the common is. I don't know. The last one I just did, white, was common. But it wasn't Adams Rite. So we're going to quickly figure it out. Because you've got two conditions that you have to satisfy. No buzzing, buzzing. No buzzing, buzzing. And only one combination of these wires will allow that. So we're going to proceed with red to red, completely random. Black to black. What do we get? We get buzzing. Okay, let's just do this. No buzzing. Interesting. So buzzing in this scenario. Let's drop out the black wire and let's pick up the white wire. So there should be no buzzing here. And if I get buzzing when I push this down, I know the red is the common. Yeah, okay, so this does not work. I get no buzzing in either condition. That probably tells me that one of these is normally open and one of these is normally closed, and it probably tells me that the black is the common. So I'm going to grab my black, and the probes don't matter in terms of polarity. I'm going to grab this. I'm going to grab the red. We'll either get buzzing or we won't. We're getting buzzing. Depress that, no buzzing. Now, I'll get rid of the red. I'm going to grab the white now. I should get buzzing. I don't. I get buzzing there. Okay, I'm confused. Okay, no, I'm not confused. I was confused. I get continuity with black as common and red as normally closed. When I push this, that'll fall to normally open. No buzzing. Now, when I grab the white wire, I should not get buzzing. Okay, now I should get buzzing when I depress this. And I do. So that's black. And then one of these wires, we'll call that one normally open. And we'll call the red normally closed. Yeah, that makes sense. So I'm going to make note of that. And I've already kind of forgotten. B equal com, R equal W equal. So black equals common, and red equals normally closed. And C and white is normally open. And I'm going to double check that because I don't want to send myself off a cliff. Yeah, okay, no buzzing, so that's normally open. Okay, we've now identified them. I'm going to assume that these wire configurations for the other switch are just simply the same. So I think what I'll do is I'll gather some hardware and we will wire all of this. And we'll literally take a look and see what it looks like when it's all wired up. Just to help reinforce the concept of what we're working on. Like what actually happens when you do something in this type of circuit. So I've got my little note of what wires are what. Black common, normally closed, normally open. Red and white. And let's play around. Let's do that. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's screw around with a basic circuit. So I've got a mag lock here. I literally pulled this off my junk pile. I don't know what it is. Well, I don't know who made this. I have no idea. I got 4 wires hanging off of here. I assume because the principle of a mag lock is so simple that it probably works. This is just an armature, probably from a Locknetics 390. I've got these laying around. So I was walking back, grabbed one of them. And so, the first thing we had talked about is, well, hitting the touch bar, or hitting this, obviously, and the mag lock lets go. Okay, well, that'll be fun. Let's experiment with that. I got 4 wires on here. Obviously, I'm thinking black and red are power. But, you know, I don't know what's what. Luckily, with a multimeter, you don't have to, you know, you can get by not knowing what the wires are because you can test it. So, let's test it. I'm going to, sorry. You can see my multimeter, right? So I'm going to test for ohms. Ohms will tell me when I've got the 2 leads for the motor. So obviously my first guess is going to be black and red. Again, polarity does not matter because all we're doing is setting a microcurrent through here. I get nothing. I get no change out of the display on the multimeter at all. I get no change. So that tells me that this maglock is NFG, or I just don't have the right wires. So because we're not sure if it's no good or not, we're going to go through and check the other options here. And by the way, this is my ever faithful Locknetics 510 that I use to power stuff. Let's go through all of them. We'll stay black and then we'll go to white. I get nothing. Oh, check it. Yeah, we'll stay black, we'll go to blue. I get nothing. Let's go to red. We already checked red and black. Let's check red and white. I get nothing. Red and red. Oh, I get voltage on red. I get something on red and blue. Red and blue. White and black, I got nothing. Red and blue, I got something. Didn't I? Yeah, I get ohms out of red and blue. So those two could be the motor. What did I get on red and white? Nothing. Red and blue. Ohms. Black and blue. Nothing. White and red? Nothing. Blue and red? Nothing. So is it black and... It's blue and red? Yeah, blue and red. So, I'm thinking blue and red. I'm thinking blue and red, we're going to get power. Now, the other thing, these other two doodads could be a door position switch, basically, a door status monitor, where there's a magnet inside of here, and it'll change state. Actually, let's check for continuity on black and white. Yeah, we get continuity there. Let's bring the plate to it, and the fact that, let's bring the plate to it, and check continuity on black and white now. I get continuity there. Or it could be a magnetic bond sensor. Okay, so we're going to run with blue and red being power. And then we'll check. Are we getting... Oh, I got to switch to ohms. Okay, yeah, I was getting... Okay, I'm getting ohms out of blue. So this could be a magnetic bond sensor. And the way that we'll test what white and black are is by, when we get this under power, we'll see if the state of these wires change. So R plus B equals power. I don't know what voltage this is. I literally have... This may be a Locknetics 320. I'm completely guessing. Okay, so let's do this. Let's wire this. I know that my Locknetics 510 works. I was just using it yesterday. And so what I'll do is I have some wires already wired here. And I know that my red is red and that my green is black on this. So I'm going to go just red to red. And I'm going to put a wire nut on that. Pull off a little more wire on this. Exposed wire. Okay. So I've got my 2 red wires. I've got that capped off. Now I'm going to go what I know to be negative from my power supply to this blue wire. I'm not going to worry about capping those off just yet. Actually, I will, just because it helps hold it all together. Okay, so we're going to power this. Let's plug, which means, in my case, just plugging it in. Okay, so I don't know if I've got voltage going here or not. It's a maglock, so it's silent, obviously. But when I get this close to it, when I get this armature close to it, if there's power, oh yeah, hey, look at us. Look at us. Now, let's be fancy. Let's have some fun with it. Let's unplug the power supply. There it goes. All right, now we know we've got power. Okay, let's go back and check continuity on black and white. Let's plug it back in. So I'm assuming there's voltage there. Oh, maybe put my continuity. So there's probably no continuity here. Oh, there is. Okay, so the question is, does it change if it's a magnetic bond sensor? Stress my wires. Okay, we still have holding power. So let me check and see if there's continuity now. There is continuity. Magnetic bond sensor, door position switch. Well, we sure know that we're powered. And obviously, because this switch is not wired in yet, nothing will happen. So, let's do this. Let's actually look at the installation instructions. I'm hoping this is a 320, so let's switch to the screen view and take a look and see what we're dealing with. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. And I don't wire Locknetics 320s often, and I do think that is what this is, because I believe that it is. Locknetics 320, I'm sure I've got a wiring diagram. Yeah, right here, wiring diagram. Right. Aha. There is no circuit board on our model. Okie dokie. Check this out. So we're wired right now with blue and red. Blue and red. We should have been getting ohms out of red and white. And we should get ohms when we're tying off red and black and blue and white. Okay, so we don't have this powered correctly. Our circuit, this model. There is no circuit board on this model. Actually, I could have wired this with a circuit board. I believe I have an old circuit board here, but that doesn't matter. That just would make this more work. Red, black, blue, white. Those are the wires we have. So right now I'm powering this with 24 volts, and I've got blue and red. Huh. Well, that means then that we should probably be powering it with 12 volts. I think that's okay, because it'll do either. So let's experiment with this. Let's actually wire it the right way. Okay, let's try this all again. We're powered, so let's be mindful of that. So we're set up on 24 volts. So I'm gonna disconnect the power supply, and let's grab our 4 wires and wire it correctly. But I should be seeing continuity out of red and white. I think I was. We're unplugged. Let's get the wire nuts off. Get the armature out of the way. Okay, so we should get, I'm sorry, not continuity, we should get ohms. We should get ohms. Well, we should get continuity. Let's check for ohms across red and white. Okay. Now let's actually wire it the way that they show to wire it. By tying off blue and black. Now let's check for ohms against red and white. Yep. Okay. Installation instructions, you win again. Okay. Yeah. Okay. Installation instructions, you win again. We're going to go 24 volts. I've tied off black and red, black and blue, like it says. Let's now wire. Let's wire it back up. We're unplugged. Red to red. Well, you know what? No, let's not. Let's leave black and blue just tied off. Okay, that was warm. Interesting. So, now that we know it works, we know what wires to use, we're good. I'm going to put this down here. Power. Let's just wire this. So, I have one happy leg here. We'll use these. Just to prove that this all works. So, I've got to bring power to my leg. I'm going to bring, and we said common was black. I'm going to bring my positive leg to my common wire. I'm going to wire the power coming in from the power supply to the load with my common so that I've got voltage over my common. And because this is a mag lock, I think what we want to do is wire this normally closed. So between black and red, we should get continuity. Between black and red. Yeah, we do. We're good. Okay. So we want power to go through when this trigger is out. So we're going to use this wire because I just checked for continuity. If I use the white wire, there's no continuity. That means the only time it would be powered is when I did that. That's no good. So red is normally open. No, forgive me. Red is normally closed. Okay. Now, what's the last thing to do? What is the last thing to do? Let's take a look at what the last thing to do is. Let's think this through for a minute. Let's get rid of that common wire. I'm not barking up the wrong tree. Okay, so the let's get rid of the negative, as I've been taught. Let's just run the negative back to the negative. Negative here is going to be white. We are not plugged in. Let's just tie off this wire. Yeah, I see what's happening here. You might start to see it as well, but if you don't worry. Let's wire nut that off. Now, okay. So we got 2 wires here, and we want to pass those 2 wires basically through a light switch, which is this. So, common needs to go back to power. And that's because there's nowhere else to put it. Well, there is. Common can go back to here, but then how are you going to power this? I suppose it would work. Then we need our red wire, and the red wire is going to go back to the load. And then let me twist this off and we'll study what we're talking about, what I'm thinking I'm doing. I've got my negative load. That's done. Cross that off. That's the way that it's taught in the DHI class. Get rid of your negative loads, your negative lines. Just tie them off. Draw them in. I got power going through the micro switch. And the only time that this power from the power supply will go through the micro switch out to the normally closed leg to feed that power is when we do this. So, let's test it. Wait a minute. Yeah, we're good. When I plug it in, I should get power off of this, and I'll know when this gets slapped down there. So let's. Okay, now we've got. Actually, let's just be cool for a minute. Let's measure voltage. We should get voltage here. We should. Wait, whoa. Yeah, we should. We have this backwards. I've got the wrong leg. I have the wrong leg. I'm getting voltage when I depress this, which means this will not work. Oh, wait a minute. Now I'm super confused. That works there. We let it go. Oh, no, I had it right the first time. I'm measuring the wrong 2 legs for voltage. Yeah, okay, I was measuring the wrong 2 legs. Now we get voltage. And the fact that it's negative just means I've got the poles reversed. All right, let's wire cap off one of these power leads. And let's toss one on one of the others. Oh, let's unplug that. Let's retwist our wires. Let's stuff it in there. Now we lost these. Okay, let's plug it back in. This is it should clap on here, and it does. Okay, it's good. That's on there. When I hit this, it should drop off. It does, and that's how you exit. Okay, we're having fun. So that's clamped on there. Let's leave that on there. Now, what do we use the other micro switch for? So hitting the touch bar will allow us to exit. That's awesome. That's handy dandy. Let's now think about what we'd use the other leg for. Let's talk about access. Let's talk about access control. So let me grab something that will serve as access control. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, here can be an example of access control. We're still powered. I grabbed a key switch that has two lights on it. This is a Locknetics 653-14L2. I have a lot of odd Locknetics laying around. So basically I got two lights. I've got two wires on each. Well, gosh, that's pretty easy. So what do? Well, we do the same thing we did last time. Let's put the light here. Let's pull our power. I don't like working circuits when there's power. Okay, so obviously, oh, this is a great example actually. All right, here's an example. Not powered, right? That is our negative leg. Let's run this wire up here. Let's bring in our other wire over here, and then I'll talk about what I'm thinking. Let's plug it in. All right. Let's take a look at this. I'm thinking that I just have this. Okay, when we hit the touchpad, our green light comes on. That's awesome. So, I think what needs to happen is let's pull the black wire off the LED and let's go to the normally open wire on the switch. Yeah. This should give me a light all the time. It doesn't. It does not. Yeah. Let's study that for a minute. Okay, I needed a minute to figure out what I was doing wrong. So, what I want to have happen is I want to have this green LED only active when I exit. So right now we have holding power. When I hit the touchpad, my green light goes on. That's what I want to have happen. We're good. That's what I want. I'm going to wire that. Otherwise it's off. However, I want the red light to be wired at all other times. My red light to be illuminated. So, one of these will have to go back to power. And one should go back to the other switch. Let's just quickly test that. It should always be red when I'm energized. So yeah, so this should just go back to power. This other light. We are not plugged in. Okay, what I want to see happen is, wait a minute. Let's well, shit. Okay. No, we're good. We should see a red light, and we don't. Why is that? Why is that? Red light. Let's go back to the drawing board. Let's check continuity against red, white, and black. Ouch. I want continuity on I'm not getting it. I get it there. Go back to where we were. And we'll be getting that green light until we bring the common in. Green light. All right, let's analyze this. So we got a green wire when we exit. What I want is the red wire to always be on when we're in the locked condition. Hit that. There's residual magnetism on that magnet for sure. That's not desirable. I can pull it off. Okay. So, studying this, green when we're exiting. How is green getting power? Green is getting power because the common of the switch is connected to incoming power. And the one... okay. And the one leg, yes, I see. And on the so the common of the switch is getting power. We are taking our normally closed leg of the switch and going back to complete the circuit. Once the circuit is complete, the power goes through the maglock, out through the other leg, back to the power supply. So we have a circuit. So common is getting power off of the positive leg from the power supply. The normally closed leg is completed. When that switch is hit, it can pick up, it gets its power when the switch is closed and completes the circuit. Now, using that logic, that means that one of the two legs of the light has to go back to power. And the normally open wire has to go back to the other leg coming off of the maglock. Powering it on one of them and wiring it on the other. Let's get rid of this. Let's run our normally open wire around our other power leg. Okay. Then the other leg of the wire needs to go back to power, so it should go back here. Before I twist that, let's plug it in. We got something's flaky here. Something's flaky here. Didn't like that. Yeah, it makes sense because we've got it powered directly to incoming power. We don't want that. Power through the common. That makes sense. That'll always get power there. Well, that should be working. Wait a minute, wait a minute. Yeah, this should always be working, and it does. There's no control here, obviously. That has to go here. That has to be depressed. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. I'm not getting the operation out of this that I want, so let's take a new approach. Let's get rid of some stuff here. So, going back to just the way that we're taught to do it, let's tie back all the negatives, all the black wires. And in my case, that's negative. And what I mean by that is negative is my green wire, my green power wire coming in. You can't see it here, but that's the power wire. So let's tie all of our, actually, let's make sure, is the white negative on the mag? Yeah, white is negative on the mag. It's called out on the instructions. Negative, negative. Let's tie back all of our negatives for all of our loads. Okay. Tying back all the negatives. So we've got 3 loads here. We've got the mag lock, obviously, and then 2 LEDs. Okay. All right. Okay, now the common, we've got to run our common, which is black, to our positive line. That we know for sure. So this has to go here. Well, actually, let's take a look. Common's got to go to positive. Okay, common has to go to positive. Then, I'm confident that that's correct. So right now, we've got all of our negatives from our loads, LED 1, LED 2, and the mag lock, tied back to negative. That's good. Our common is picking up power from the positive. Then it strikes me that we need to have normally open, our red wire, going to the green light. Wait a minute. I think it should be the white wire. No, it's red. Red is normally closed. Right. Red is normally closed. Alright. So, red is normally closed, which means it's going to get power when we're like this. So that means that the other load line for my maglock and my green LED needs to go back altogether. Now, when I plug this in, I should get a maglock and a green light. I do. When I hit this, both the maglock and the green light should turn off, which they do. Okay, now, that means that our normally open wire, I should only be getting continuity when this is pushed down. And I am. Okay, that means that means the normally open and the other power leg from the LED should go back here. Yes, that seems to make sense. When I plug it in, I should have a locked condition and a green light. And when I push this, I should have an unlocked condition and a red light. We're locked? Okay, so the problem is we've got a red light all the time. Red light all the time. Yeah, because we're continuously powered through these two legs. Okay. Let's study it. And let's review. So we're good. We've got power and a green light. We let that go, no green light, and we're good. Now what we got to do is figure out how to get the red light illuminated when the normally open falls normally closed. So, in order to do this, we've got power going to the red LED on one leg to it. Common is powered. The only other thing we need to do is pick up power on the normally open leg when we close the circuit, which means the only way to complete the circuit is to tie these two wires off, the normally open wire and the other LED leg. Bingo. And we're unlocked. Buzzing. All right, now, this is what we wanted. Let's study what we did. Now, and then we're going to talk about something super cool. We'll make this actually super cool. So let's get the camera and let's summarize here. Okay, so what needs to happen is, to make this somewhat easy-ish, we're powered. Job 1, tie back all the negatives. I've got negative power. I've got my negative power coming in right here. That's this green wire. Sorry, it's green. I should have picked black. This is my negative from the installation. I'm sorry. This is my green wire. That's negative going to the power supply, the 510. That goes back here. You can see the green wire on terminal 5. Let's tie back all the negatives. Negative from the load, the mag lock. Okay. Negative from the two LEDs. I got a negative LED and I got a negative LED. So right there, the bottom line is that gives you half of the circuit. You're half done. Boom. Put that away, and you don't have to think about it. Step 2 is give power to your common. So I ran the black leg to the black common wire to the positive. Great. Now I can energize this because I'm actually picking up power, and the only thing that's left over, circuit coming in, it has to flow in a racetrack. The racetrack has to be continuous. I'm now running power to this, and the only way that I'll get action out of the two normally open or normally closed is when I connect them to a way by which they can complete the circuit. Actually, I think I've got... No, I'm good. I don't have a mistake. So, the easy of the two would be take the normally open and wire it to the other leg of the light that you want to turn on when your normally open is activated, which is what I just did. That makes it easy. The green light's always on. That's because we have the normally closed leg running back to complete the circuit to the load. Pardon me. The green LED is always on because we're always locked when we are in a condition of normally closed. Right now we're normally closed, meaning there's power flowing. This is normally closed with the red wire. Now it's fell open. So because the red is the normally closed, which means power will flow. What do I want to have happen in all instances in this natural state? I want to be energized, and I want to have a green light. That means that the normally closed leg has to go to the other power leg, the positive power leg of the load for the light, and the positive power leg for the electromag. Bingo. We're done. Except that normally open leg, I don't want that lit when I'm in the standard condition. What I want to have happen is it lit when the normally open white wire falls to normally closed when I push the trigger down. That's what's super cool about this. So, how can we make this even funner? Here's what we could do. Imagine the client asked, what would you use it for? Okay, think of this. Here's a second mag lock. What if on my green, normally closed red wire, I am powering the mag lock and the green LED? That's cool. What if this touch bar, when I hit it, would not only unlock the mag lock and turn on the red light, but what if it also turned on a second mag lock? So I've got two doors. I've got a security interlock, but let's not assume that this is a proper security interlock. But what if when I exited one door, I locked out the other door? I prevented that other door from operating. So let's switch the camera back and let's do it since we're already here. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so what that would mean is, oh, it's too easy and it's right in front of us. So what that means is, following our instructions earlier, we know that we have to run all of our negative lines to each other. We know this. So let me strip these wires. We know we have to tie blue and black together, and actually, yeah, we'll do that. These wire strippers are by Capri. It's a number 20010. They work fairly well. I'll bring that here so you can actually see me do it. And the sense that they not only cut the wire, but pull the sheathing off, giving you a nice wire. That's not really that much. Let me pull out a little bit more. Let me grab my black wire. Those are stripped. Let me keep going. Let me get my white wire, which is my negative. And then my positive. Okay, let's tie off my blue and black according to the installation instructions. If you recall, 24-volt operation requires blue and black to be terminated. So, what's the first thing we need to do? Let's tie off, let's tie off our negative. I have to bring this in close. I'm going to unplug this. Let's tie off our negative. That was the first thing we're supposed to do to make life easy. Cut the circuit in half right away. Terminate any wires that are negative. That's terminated negative. So it seems to me that the only thing we have to do now is bring our power wire from the second magnet over to our normally open wire. Then, what should happen? What should happen is one mag lock. When I re-energize the circuit, we should have this lock, this armature connected to this mag lock only, a green light. This mag lock and this armature are not connected and no red light. And when I switch this, I will reverse the operation. Okay. Yeah, we definitely grabbed the first mag lock. You can kind of see that red light, green light. Switch it. Boom. We grabbed the second mag lock and let go of the first mag lock and got a red light. Here we go. Let that go. Boom. Okay. Let's make a final summary on this, and we will call this complete. Hey, so that was pretty fun. So the summary is this, and we'll look at the wiring one more time. Tie back all your negative legs. Every load will have a negative. So you'll have negative coming in from the power supply. Every load will have a negative. Tie them all back. Tie them back. So I should have 5 wires connected together on my negative. And I do. I'm going to grab the camera and show that to you. I've got my two negatives from my 2 mag locks. Those are loads. I've got my 2 negatives from my 2 LEDs. Back to my 5th wire, my green coming in from the power supply. All my negatives are 5 wires terminated together. Great. Okay. Now, That's step one. Step two is going to be that common. Got to do something with the common. The black wire. So put that to your positive coming in from the power supply. Here it is. This is my common, which we proved earlier with continuity. Only 2 wires. Red going back to the power supply. Red going back to the power supply. That's my common. What's the last thing to do? The last thing to do is we have a normally open wire and a normally closed wire. In one condition of the switch, something's on, the other thing's off. Hit the switch, the first thing's off, the second thing's on. No big deal. The thing that you want, the normally closed, the thing that you want on all the time, take that common. In our case, it's the red normally closed wire. You grab the other power lead of the other load and tie them all together. It's that simple. So the normally closed wire, when you wire that to the other leg, the other unused wire from your loads, that means when you turn the power on, boom, it's on. That was our green LED and our first mag lock. Normally closed to our green LED, this power wire, and our first mag lock, this power wire. Awesome. The very final thing to do is this. When you hit the switch, that will take the normally closed wire, the red wire, and boom, make it open. No more power going through there. The first mag lock and the green light will turn off. When you do that, the normally open wire falls closed. Whatever the other power legs that are connected to that normally open, fail closed wire are now on. And that would be the leg of the second LED, the red, and the positive leg of the second LED, and the positive leg of the second mag lock. Let's look at it. All right. Normally open leg. When I hit the switch, red light goes on, the second mag lock would clank. Yeah, it did. Normally open. Second power leg to my second LED. Second power leg to my second mag lock. That's it. This works. So that would be, I can't say a common use for this. But you might want one door locked when the other door is not locked. It's a bad example because you wouldn't use touch bars on those because there's no latch. Well, there's latching, but yeah, it would work if you were going to exit. Hit the touchpad. Mag 1 falls out. Locking mag 2. You do not want 2 people in a room at the same time. You don't want 2 people to enter the same room at the same time, let's say. So you could hit the touch bar, enter the room, that will automatically lock the second door. There will be a visual indicator, green when you're good on door 1. When door 1 is locked, red on door 2 when door 2 is locked. Let's just say that's what you're using the LEDs for. That works. But again, you're not limited to how you would use these. I just happen to turn LEDs on and off and mag locks on and off, and it's because that was the hardware 10 feet away from where I'm sitting. I could have run that air curtain, which are really cool. There was a Starbucks where I used to live that had an air curtain, so every time you walked in the door, the air curtain would come on. It's nice. It keeps the bugs out. That's what they're meant for. You could just do a lot of things, whatever you're switching on and off. And you could also report back to access control on all of this stuff. So this experiment was a lot of fun. I hope that we all learned something. I know that I did. I had to think that through critically a couple of times and realized my first approach to wiring wasn't correct. And what did start kicking in were the 2 or 3 classes I took at DHI, Core 133, and then EHC 4. There were probably 3 different classes. And it did, excuse me, occur to me that every time they were saying, get rid of the black wires, just tie them off. They're done, they're easy. It's a freebie. You're getting rid of half the circuit. And once you get out of your head all those other wires, 2, tie that common back to the positive, incoming from the power supply. Okay, now I just have light switches. So you'll have the normally open and the normally closed wires to deal with, and then you'll have the power leg from each of those loads that you tie back with that. You're done. Okay, awesome. If there's any questions, criticisms, or concerns otherwise, please feel free to reach out to us. Thank you. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Alright, let's add insult to injury and take a victory lap. Let's draw a quick down and dirty wiring diagram of what I did. Let me move all of this out of the way. Yeah. Alright, yeah. Let's take our origin and let's just move it. Okay, so let's draw a quick wiring diagram. So you get the idea. Let's call this our power supply. Great, power supply. Let's take all of this and let's copy it here. Let's copy it here. mag 1, mag 2, LED 1, LED 2, okay, let's do this. Let's do normally open. Normally closed. Now, let's see if I can make this without really mucking it up too terribly. Yeah, and by the way, everything that I wired, I had one more single pole double throw switch. I never used the second single pole double throw. I never even used this one. Never even used it. We'll leave it there. So the first thing to do is to bring all of our negatives together. So, negatives. All of our negatives. We have 4 loads and a power supply. So, the circles will indicate a termination. All of our negative leg coming off the power supply and our negative legs of all the LEDs are connected. That's one. Number 2 was connect the common to positive. So, I think what I'd like to do is grab our second single pole double throw and let's just move it out of the way. Let's run. Let's tie our negative to our common. Okay, that was the second thing. Now, on our normally open, I'm sorry, on our normally closed. Yeah, let's do this. Just to keep the drawing slightly cleaner. Just allow me to be slightly... Okay. Keeping the wires from crossing over each other. It's going to prove to be impossible. Actually, not really. Hitting the spacebar keeps you in the tool. Actually, it doesn't. It does in VCarve Pro. Okay, so our negatives are tied, are all tied together. And the only thing that we're really trying to show here, I don't want lines to cross over each other. So, normally closed, that means mag 1, okay. So our normally closed means mag 1 and LED 1. Those are going to be wired. So, this is called the swinger. Let's put the swinger there. Normally closed. So that means then that we have to run from here Beautiful. All right, does this match what we're doing? Step 1, all of our negatives are tied back. Yep. Our common has positive voltage coming in. Yep. When the switch is in its normal condition, it's closed, powering mag 1 and LED 1. When we depress the micro switch, the swinger falls down here, powering mag 2 and LED 2. That is your wiring diagram. Let's do this. Let's do this. Let's do this. Save. Put it in the right directory. Beautiful. Simple, elegant. It's a lot easier. It took a lot faster to draw it. But that's the ticket right there. That's the ticket. Okay. Thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.